it's time to set up Camilla DSP. So I'm going to navigate to moOde. So mine is at tablesubwoofer.local. Yours, if it's default, will be at moOde.local. I'm going to click on the M on the top right and click on configure. So here under configuration settings, I'm going to click on Camilla DSP. Now what we want is we want to create a new pipeline. So I'm going to click on new and let's call it active subwoofer. Okay. Okay, so that pipeline is created and now I want Camilla DSP to use it. So I'm going to click on active subwoofer here and I'm going to click on save. So what that's doing now is that's starting up Camilla DSP and making it use my active subwoofer setup. Cool, so Camilla DSP is active now. That active subwoofer pipeline is effectively the default one, which does nothing much. So it's now time to edit the pipeline. So to do that, turn on the pipeline editor and click on open. Okay, so this is Camilla DSP's pipeline editor. We currently see that the state is offline. So I'm going to choose the table subwoofer on my iPad and I'm going to press play. And what you should see is Camilla DSP coming online and you can see inputs and outputs there. Camilla DSP is now running. Great. So I'm going to pause that. And what should happen is now, yep, you can see the inputs and outputs are flat. Okay, so that shows us that Camilla DSP is actually working. Cool. And when it's paused for a while, Camilla DSP switches off, back to state of offline. Okay. Now, looking at these tabs, we first have the devices tab. Now, the one important thing to note when it comes to this is with regards to the buffers. Now, chunk size, what does that mean? Okay, so chunk size tells Camilla DSP how many samples to use for processing. So at the moment, it is using 4,096 samples in order to process. Now, what that does is it basically tells Camilla DSP to hold those 496 samples, process them, and then send them on. Now, what that effectively does is it adds a delay of a certain amount of samples to your signal processing. So let's quantify what the delay is for 496 samples. So if we have 4096 samples and we have a 44.1 kilohertz sample rate and we times it by 1,000, we see that that adds a 92 millisecond delay for Camilla DSP to do its processing. Now, as you reduce the chunk size, you increase the processor power requirements for actually performing this processing. In my case, I'm going to be using a 1024 chunk size, which gives me a 23 millisecond delay because my Raspberry Pi Zero2W can handle that. I apologize. Raspberry Pi Zero2W can handle that. So I'm going to go in now, change my chunk size to 1024 for my 23 millisecond delay. And now we're going to move onto the pipeline. So let's first look at what this default setup has. Okay, it's got our channel 0, channel 1, something called master gain, and some outputs. Okay, let's first clear it out so we can start from scratch. Click on delete those steps, go to mixes, there's no mixes, click on filter, delete this filter. Okay, let's go back to pipeline and try and understand what's happening. Okay, so we've got our two channels, channel 0, channel 1, which are our digital inputs to Camilla DSP. And then we've got these output channels, channel 0 and channel 1, which go to the amplifier. So all the processing happens between these two. Now, channel 0 corresponds to the left channel of my Pi DigiAmp Plus, and channel 1 connects to the right channel of my Pi DigiAmp Plus. Now, as per the way I set up the wiring, the left channel gets connected to this. Used to be an input, and now it's an output. And the right channel connects to this speaker here. So what I need to do is I need to mix into mono, and then I need to apply a low pass filter onto this right channel. Okay, so let's start with the mixing to mono. So to mix to mono, I'm going to click on mixes, click on plus. Let's call this mono output. Okay. So if we look at this mixer, it takes in 2 channels and it gives out 2 channels. Great, that's exactly what we wanted to do. So destination 0, which is the left channel, currently just takes in the source. So it connects the source directly to the destination, left to left. I don't want that though. What I want is I want it to take the left and right and send it to the left. Perfect. That's one side sorted out. Now I want to take, for output to the right channel, the left and right. So as we can see, left and right sources get mixed together and sent to the right. Left and right sources get mixed together and sent to the left. Perfect. One thing to note though is this is going to take the full range left, full range right, and put it to the left, which effectively doubles the amplitude of the signal. Now, in order for us to halve each one so that when they're summed together, they're the same amplitude, we need to put in this gain here. Now, this gain is in dB. So let's jump over to this dB calculator and see, okay, if I want to halve the voltage, I need a -6 dB on this. So I'm going to go in and I'm going to choose -6, -6, -6, -6. Great. Okay. So I've created this mixer. Let's jump over to the pipeline, click on plus, choose mixer, and the mono output one is selected there, and let's take a look at it. Okay, great. So as expected, on the left channel of our amp, it is now comprised of a mix of the left and right. On the right channel of our amp, it's a mix of the left and right. Okay, sorted. Now, channel 0, which is the left channel, that's done. We get a full range mono output out of the terminals here, which is great. But channel 1, I still need to add a low pass filter to make sure that only bass plays out of this. So let's close this, go back to filters, click on add a new filter, and what I want is, I'm going to call this low pass. Okay, so it already sets it up as a low pass filter by default. You have a lot of options for you to set this up, but I'm just going to use a basic low pass filter of type biquad with a Q of 0.5, and the frequency, I'm going to make this 100 Hertz. So now that that is set up, I'm going to go back to my pipeline, click on plus to add the pipeline step, filter, low pass filter. Which channel do I want it? I want it on the right channel, which is channel 1, and I'm going to click plot. Okay, excellent. This is set up exactly how I want it now. My right channel on my amplifier gets passed, receives a mono signal and gets passed to a low pass filter. My left channel gets mixed into mono and gets passed directly to the outputs, which is perfect. Okay. Now, in order for me to actually set these DSP settings, I'm going to close this. I'm going to select my table subwoofer here, and I'm going to click play again. So what that does is that turns CamillaDSP on. And what we'll be able to see now is we'll be able to see these config settings here. So I can now hit apply and save. And what that'll do is that will permanently apply these settings to CamillaDSP. So from now on, only bass frequencies that are sent to this active subwoofer device will come out of here, and a full range mono will come out of here, which is exactly what I wanted. So certain things you need to consider. Adding this chunk size, or CamillaDSP's requirements to have a certain number of samples for it to do its processing, means that it inherently adds a delay. So if you have a setup such as I do, which consists of table speakers using AirPlay via moOde and an active subwoofer connected via AirPlay using moOde and expecting to use them both simultaneously, you will now find that there's a small echo because of the delay between CamillaDSP's processing of your subwoofer and your table speakers. So what you'll need to do to correct that is you'll have to jump into moOde on your speakers, enable CamillaDSP using the same buffer size, remove all processing, just connect the inputs directly to the outputs, and you should have now perfectly in sync audio.